Find a linear model using the second and sixth data points. Well, the second and sixth data points are referencing back the data points from our chart. So our second data point would be 2005 and 4,665. 1, 2, 3, 4, 5, 6. Our sixth data point would be 2009, and the y coordinate would be 5,116. So these are our second and our sixth data points that are being referenced. So what it means is we're trying to write an equation of a line through those points. So we're going to use these points to find our slope. Now remember, when we were writing everything, we said that 0 was equal to 2000. So that means that our data points are going to look like 5 and 9, and then the corresponding y values. And so if we write out what we have, our first data point is 2005. With 0 equaling 2000, that means that we would have 5 and 4,665. Then our sixth data point would be 9 and 5,716. So these are our data points. If we label, we have x1 and y1. We have x2 and y2. We're being asked to find a linear model. That means a linear equation. So we want to use our point slope form. So y minus y1 equals m times x minus x1. If we substitute in our values, well, the first thing we need is an m. We don't have a slope yet, so let's figure that out. So m is y2 minus y1 over x2 minus x1. So substituting in y2 is 5,716, y1 is 4,665, and x2 is 9, and x1 is 5. So simplifying this down, we get 1,051 and 4, which is approximately equal to 262.75. Well, now we have our slope, so now we can put everything in. So we have y. Remember, we don't put anything in for just the y. y1 is our first y coordinate, so 4,665. M is our slope, so 262.75. Then we have x minus x1, and x1 we're told is 5. We can distribute, so we'll have y minus 4,665 equals 262.75x. And then minus 262 times 5 is 1,313.75. We need to get y by itself. So in order to get y by itself, we need to add 4,665 to both sides. So that means we get y equals 262.75x plus 3,351.25. And this would be our linear model. This is the equation of the line representing the data points if we're using points 2 and 6 as our data points to write and find the slope. So in part C, it says, according to the model, that's that equation right here that we just wrote, when is the public debt going to reach 5.1 trillion? Is this an example of interpolation or extrapolation? So let's see if we can figure this out. So the model, that's what we just figured out. That is our y equals 262.75x plus 3,351.25. Now we need to be careful. It says 5.1 trillion. Well, 5.1 trillion is not the units that we were using before. Remember from our chart, everything was in billion. So the first thing we need to recognize is that 5.1 trillion is really 5,100 billion. Now we have everything in the same units, and now we can compare. So we want the public debt to reach 5,100 billion. So that means our y value is going to be our 5,100 billion. And we're trying to figure out when that will occur. So when is our x? When is that time? So We can put our 5,100 in for our y, and now we need to solve for x. So to solve for x, the first thing that we need to do is subtract our 3,351.25 from both sides. If we do that, we get 1,748.75, and that equals our 262.75x. So now we need to divide both sides by 262.75. And if we divide, we get 6.67, and this would be years. Now, this question is asking us, is this interpolation or extrapolation? Well, let's look at this and see. So we need to evaluate at 6.67, but don't forget, we said that let 0 equal 2,000. So this is really almost 2007. So it would be in the middle of the year. So let's say that we're looking at July 2007. Remember, it's the end of the year. So the full 7th year would have been December 2007. So we're looking at this to be July. Well, July 2007 is within our data set. It would be right here. Here's the end of 2007. The end of 2006 was 4,971. The end of 2007 was 5,246, excuse me. So we're looking at somewhere in the middle of those. Well, is 5,100 in the middle of those? Yes, it is. So this is going to be interpolation. Our 2007 is within our data set. It's not an exact value in our data set because we're looking at July as opposed to the end of the year, but it is within our data set. So this is going to be interpolation. And the last part, use the model to project the public debt in 2014. Well, 2014, that would be an x of 14 because we're looking at the number past 2000. So this time we don't have our y value. Instead, we have our x value. So we're using our same model, but in the place of our x, we're going to put 14. So if we solve this down, it looks like it will be 7,029.75. So that means that the debt in 2014 will be approximately equal to, I'll round it up, I'll do 7.03, or that would be 7,030 trillion. And remember, this is by the end of 2014. So that would be the December timeframe of 2014. So we're looking at the debt to be almost 7,030. So we're saying about 7.3 trillion.